Okay, so here's part B. So here we're going to talk just a little bit about where this really cool picture is coming from, and it starts in a place called the complex plane. So instead of this being the x and y axis like you might be used to sometimes, this is a complex plane, which people usually write with a z, but it just means we go over, we pick numbers like this, 2 plus 3i. So it means go over 2 and then go up 3, and we'll just pretend that's the I direction.
I.
Do you know what I is?
I think it's the square root of -1.
Yeah, what does that mean, that I is the
It's an
square root of
imaginary number.
It's an imaginary number, yeah.
Mhm.
What are its properties?
Well,
I think it's mentioned in the equation. I think e to the pi I plus 1 is 0.
Oh yeah,
Yeah.
you've heard of it there. Do we have an eraser nearby? Or do I
Here.
have to be careful about what I'm writing? E to the pi I plus 1 equals 0, yeah. That actually kind of relates a little bit to this equation that we're talking about. That we're going to be talking about. What's the important property of the number I?
that I squared equals -1.
I squared is -1. So it's just a special number, and the only property that it has is that I squared is -1. So that's neat. And it turns out there's a lot of amazing math that comes about when you study I. One of the things that's really neat is when we start with a circle of radius 1 in this complex plane. So some points on this circle, for example, 1 is on the circle. I mean, you just go over 1 and up no i's. What are some other points on this circle?
Well, -1.
-1 is on the circle.
And then there's I and -I.
Why are they on the circle?
Well, it's a circle of that radius.
A radius I
Well, but it also has a radius of 1.
has a radius of 1.
It's going up 1 unit in each direction.
Yeah, there you go. Good. Good.
Seems to be like an oval.
Well, I didn't draw it well, but it's definitely a circle. This would be 1 unit up in this I direction, 1 unit down in the minus I direction. And there are some other points on here, but here's an amazing thing that happens. If I take every point on this circle, you guys should be able to answer this question, and I call it Z. And I draw a new circle where every point Z gets replaced by the same point Z. What does the new picture look like?
So you take every point on this circle,
Yep.
and then you create a new circle where every Z on here is replaced by a Z.
The same Z. Yeah, so what's that new picture going to look like?
But wouldn't that be exactly the same as this?
That's right. Okay? And that's just like when we make a graph of the line y equals x. We've just called something y, but it's also x. So you get a straight line,
Cool.
right? Sort of the same thing's going on. But now, how about if I take each point z and I replace it with its square?
Z squared.
Now this gets interesting because I haven't really talked to you guys about how you even compute squares of numbers. Do you know what the shape is when we're talking about real numbers? When I make a graph that says y equals x squared, do you know what shape that is?
Isn't it the up and down graph?
It is. It does go up and down. Do you know what its name is?
It's a graph.
It's a special kind of graph. You know.
It's a parabola.
It's called a parabola. But in the complex plane, there's an amazing thing that happens with this map, where you replace just this circle only. With every point goes to where it's squared. Where does 1 go to?
Well,
It
it
stays.
stays.
Where does -1 go to?
1.
Where does I go to?
It stays.
No,
But
but
no, it goes to -1.
Where does -I go to?
minus I, doesn't it go to 1?
Yeah.
Why?
Well, because it goes to -1 because -I squared equals I squared.
Yeah, you have -I times -I, so the minus times a minus is
Yeah, plus
a plus, and the I times an I is,
I squared
which is
-1.
-1.
So the 1 stays, the -1 goes to 1, the I goes to -1, and then the minus I goes to -1.
Yeah, and it turns out what happens is that the circle stays the same, except it wraps around itself twice.
So you get a double circle.
You get a double circle.
How do you make the double? If it's on the exact same lines, it would just look exactly the same.
Yeah, that's a great observation. It would look the same, except it wraps around twice. So how do you tell it apart? That's a tough question.
Yeah.
What do you think happens when you go z goes to z cubed?
Maybe you get a triple circle.
Yeah, so the circle in the complex plane is really easy to understand under these maps where you take squares or cubes or fourth powers. What do you think z to the 100th does?
You get a circle that wraps around 100 times.
100 times.
Whoa, crazy, right?
Yeah.
It's pretty interesting. And the only other thing that we need to talk about Dan's math is what happens when I divide here. What do you think would happen if I took every point and took it to every point here and I divided it by 2? What do you think would happen?
Well, would you get a half circle,
Well, one.
or would it shrink?
1 would go to a half.
I would go to I over 2.
I would go to I over 2.
Minus 1 would go to -1/2.
Then minus I would go to minus I and a half. Minus I over 2.
Okay?
So it would shrink.
Seems like it shrinks. I'm dividing it by 2. I'm getting a circle whose radius is half. What if I divide it by 10?
Then you get a circle whose radius was a tenth.
What if I divide it by 1/2?
But then you double the circle.
Ah, interesting. I double the radius.
Yeah.
Yeah.
Okay, cool. So that's all we need to know to see what happens to Dan's map. Okay?
Alright.
You ready to take a look at it? We'll draw it by hand.
Okay.